Dynamic approach to programming is a method of optimization. It basically means to store results against unique values so that when you run into those values again, you don't repeat the same operations, you simply pick out the result against the value. Welcome or welcome back. This is a week in dynamic programming. The first question really bummed me out because it was listed under easy, but it took me over 4 days to figure it out, and even after that, I actually had to look it up. My error was that I was finding out all the possible sub arrays of an array and then finding out their sum when the question did not really require that. The solution I ended up implementing was Kadeen's algorithm, which is a mix of the greedy approach and dynamic programming. It is worth noting, though, that in most DP questions, the greedy approach doesn't really get you anywhere because the greedy approach basically is to choose the highest or the lowest quantity every time in every iteration, and that does not always guarantee that you would end up with the most optimized solution. In dynamic programming, it's always better to just figure out the recursive solution first, like the simple solution first, rather than memoizing and optimizing it right from the get-go, at least for the first few times anyway, because otherwise it's just complicating things for yourself and making it more confusing than it needs to be. Beyond the first question, which took me quite a long to solve, the other questions seemed pretty easy. I mean the easy ones anyway. So the thing is, once you come to know that a question can be can be solved using dynamic programming, solving it isn't the difficult part anymore, because as far as I have encountered, questions which ask how many paths, how many ways can you do certain thing, what is the best way among numerous other ways, those are the questions that typically need DP to be optimized. For example, if a question asks you that among a certain number of paths, which is the shortest path that you can take, that can be solved using DP. The coin change problem is one of the classic ways to show that the greedy approach doesn't always work for dynamic programming, because in this question you are given a bunch of coins of different values and you have to pick the minimum number of coins that add up to a certain value. For example, if you are given 3 coins, 1 rupee, 4 rupees and 5 rupees, and you have to add up, make the total equal to 8. If you go by the greedy approach, the answer would be 5 plus 1 plus 1 plus 1, which would be 4 coins. But it's obvious that that is not the correct answer, and the correct answer is 4 plus 4 equal to 8, which is 2 coins. So if you go by the greedy approach and always choose the maximum or the minimum quantity at every iteration, that does not really always guarantee getting the most optimized solution in the long run. One thing about lead code is that you can always see that exactly against which test case your program is failing and what is the reason for that. So you can always like test it against that specific input, which is not something that you get in coding competitions or like maybe interviews. So because obviously they won't tell you against exactly which case it is that your program is not functioning properly. You have to figure that out yourself.